Hello, welcome to this session, a session where we're going to discuss how best we can prove and apply the factor formula. We oftentimes found problems with it. Some of us know it very clearly, others find some little problems. So after this session, we shall be able to tell whether really it is very difficult or very simple. From compound angles, you learned that the sine of, say, angle A plus B, you say it was cosine of A, cos of B. Then you maintain this sine plus cos of A, sine of B. This is what you say, or this is what you did when you're doing compound angles. If I call this one my equation 1, you also say the difference, and you say sine of an angle, say A, minus B shall be sine of A cos of B minus, for sine ratio, we normally maintain the sign in between two different angles that are given, minus cos of A sine of B. When you look at equation 1 and equation 2, get its sum and get its difference. When you get 1 plus 2, when you get equation 1 plus equation 2, it will be sine of A plus B plus sine of A minus B, that is equivalent to, when you add this to this, since it is the same, we get twice of sine A cos B. So we get twice of sine of A cos of B. Now, when you look what these two, when you add cos A sine B plus negative cos A sine B, you end up getting a 0. So you call this one another equation, say equation 3. Now, after getting the sum, get the difference as well. As you're getting the difference, make sure that you maintain your stand that you're getting equation 1 minus equation 2 now. When you get 1 minus 2, we shall say it is sine of A plus B, which is sine of A plus B, minus, we are subtracting off sine of A minus B. That is equivalent to, now what you do this side is what you do this side. We are assuming to put a negative here because we are subtracting. When you get to this, it is sine A cos B minus sine A cos B. Remember, this is the same. So this will cancel out. When it cancels out, you remain with cos of A sine B minus cos of A sine B. In this sense, since this is positive, minus a negative, the negative cancels with the negative to form a positive as well. So we shall have 2 cos of A sine of B. Call that one your equation 4. When you look at equation 3 and equation 4, it is only sine. But we are talking about compound angles. You talked about both a cosine ratio and a sine ratio. This is for sine, and that is done. Now, for a cosine of the same angles, A plus B, you say it is cos of A, cos of B. Since it is plus, it changes into a minus. If it was a minus, it could just change into a positive. So we shall have minus sine of A, sine of B. Just like you've seen a ratio for addition of the two powers in the cosine expression, do the same with the minus like you did here. So we shall have, what about, call this one equation 5. What about if someone has cos of A minus minus B? We shall have cos of A cos of B. Now this is being negative. From compound angles, it it ends up becoming a positive here. So we shall have plus sine of A, sine of B. Call that one equation 6. Hope you remember how we did this, how you got these two. After the sum and after the difference, do the same here. Get equation 5, add on equation 6, and see the expression you're getting. After that, get equation 5 and subtract off equation 6, and also see the expression you'll be getting. When you look at the two, you get 5 plus 6. Now we are adding this. It is cos of A plus B. It is cos of A plus B plus cos of A minus B plus cos of A minus B. When you add the two, look what it is. This one sine A sine B and sine A sine B, they look exactly similar. When you add the two, it will be a negative sine A sine B plus sine A sine B. This one will cancel and give you a 0. If it gives you a 0, you remain with this, where you have cos A cos B plus cos A cos B, giving you twice of cos A cos B. It will be twice cos of A cos of B. Call this one maybe equation 7. If that is the case, do the same with subtraction like you did here. So if you get equation 5 and subtract off equation 6, sorry by sorry, we shall get there. Equation 5 is cos of A plus B minus, we are subtracting off cos of A minus B, minus cos of A minus B. We shall be having, now you get this, cos of A cos B, which is exactly the same as cos of A cos of B. This will cancel to give you a 0. Remember, this is negative. Negative sine A sine B minus, remember now we are subtracting, minus sine A sine B. It is negative minus a positive. So if it is negative sine, this one, then minus sine, you end up getting twice of the negative. So we end up getting minus 2. Hope this one is understood very easily. This is negative. Let me be a bit clear here. It is negative sine A, sine B, minus, because now we are subtracting, sine A, sine B. Since they are two, when you put out this negative and you say I'm factorizing out the negative, inside remaining the positive. If that one happens, it will be this one plus this, giving you twice of sine A, sine B. But remember, there is a negative outside the bracket that will multiply to form negative 2 sine A, sine B. That's why I'm having negative 2 sine A, sine B. Call this one another equation, which is now equation 8. If this is what we have, remember our target is to find out, is to derive, is to find the expression that we call the factor formulae. Look at equation 3, equation 4, the results of both addition and subtraction for both cosine and sine. When you look at this, we have two angles, AB, AB. Now, if you let, if maybe you let, if you let A plus B be any unknown of your choice. I'm choosing M, and I always choose M if I'm given a chance. M and A minus B, maybe you let it be any other known, say N. Say N. When you look at these two, try solving the two equations now simultaneously. Now that we are using simultaneous equations, you get equation 1, though I've not named it, and this one equation 2, you can name them accordingly. Then you solve them using the knowledge of algebra. So we shall have A plus B giving us M, and A minus B giving us N. Since these two have the same signs and the same coefficients as well, we add. When you add, you'll have twice of A. This will cancel out because positive B plus minus B is a 0. So we shall have m plus n. If it is m plus n, we want to make A the subject now. So you divide by 2, you divide by 2. So we shall have A as m plus n out of 2. After getting the value of A, you put it in any of these two equations so that you can get the value of B. So we say, in doing that, you will be putting it back to get the value of B. However, somebody may say, what if I just add this and also subtract? Because if I subtract, then I will consider this. When I was adding, I consider because they were of the same sign. So when I subtract, then I will consider this. And these ones will go. Anyway, you can either put this on any of that one, get the value of B, or you subtract these two equations. The easier one will be subtracting, I think. So if, say this was 1 and this was 2, if 1 is made, if we get a difference of the two, we shall have A plus B giving us m, then A minus B giving us n. So when you subtract, these two will automatically go. So you'll have B minus minus B giving you twice of B equals m minus n. Now that you want to be the subject, so it is divided by 2. Divide by 2. Then you shall have B as m minus n out of 2. Look what these two. These are the values of A and B as proven here. Now, when you look at our equations back, look, I told you, look at where you had the sum, the subtraction of sines, and then the sum and subtraction of O and difference of the cosines. If you look at this one carefully, they choose these two equations, the sine sum, the sine difference, the cos sum, and the cos difference. Substitute, wherever you find A, substitute m plus n out of 2 on the side where you have the product. So instead of A, we shall substitute it with m plus n out of 2. So from let's start from equation 3. From equation 3, where you have sine of A plus B plus sine of A minus B. This one is equivalent to twice of sine A cos B. After getting this, now that we have the value of A and we have the value of B in terms of m and n, as well as we have the value of m in terms of A and B as well. So where there is A plus B, you put there m. Where there is A minus B, put there n. And where there is A, put there the value of A in terms of m and n. So is B. Where I find B, put there the value of B in terms of m and n. So we shall have sine of A plus B, which is m, plus sine of A minus B, which is n, shall be the same as, now our A is m plus n over 2, which is twice sine of m plus n out of 2. Then our B is m minus n out of 2. So it is cos of m minus n out of 2. In brief, the addition of two sines normally give us twice sine of m plus n out of 2, cos of m minus n out of 2. That is why, if possible, somebody may just say the sum of two sines is equal to twice same sum cos same diff. Hold on. It is twice you can say twice sine, same sum, cos, same diff. You're talking about twice same sum. You're talking about a half of the sum and a half of the difference. That's why you can easily say twice sine, same sum, cos, same diff. Diff referring to a difference. And when you have this, that is the factor formula for the addition of two sines. Now, about the subtraction of two sines, you go to equation 4. From equation 4, it is sine of a plus b minus sine of a minus b, that is giving us twice of cos of a sine b. Just make a substitution, just like you did up. So we shall have sine of m minus sine of n, giving us 2 cos m plus n out of 2, sine of m minus n out of 2. So wherever we are subtracting two sines, so we get twice cos same sum, sine same difference, or sine same diff. This is the factor formula for the subtraction or for the difference of two sines. Now that from equation, look at 5 and 6. The result of 5 and 6 as regards the sum is this, equation 7. So from equation 7, we have cos of A plus B plus cos of A minus B. This is equivalent to twice cos of A, cos of B. If that is the case, we still do the same substitutions. You have A plus B in terms of M and A minus B in terms of M as well. You have A in terms of M and N as well. So do the substitution, just like we've done here. So we shall say it is cos of M plus cos of N, that is giving us 2 cos of M plus N out of 2. Then cos of M minus N out of 2. This one becomes the factor formula for the sum of two cosines. Lastly, we are looking at the difference of cosines. I'm going to wrap up the first part. Hope you're following clearly, and if you've been noting down and if you've been writing, I hope everything is moving on as planned, as mostly as I'm saying it. Now, from equation 8, so from equation 8, we have cos of A plus B minus cos of A minus B is equivalent to negative 2 sine of A sine of B. Now, do the substitutions as been doing. So we shall have cos of M minus cos of N is equivalent to negative 2 sine of A, A is M plus N out of 2 sine of M minus N out of 2. This one becomes the factor formula for the difference of two cosines. All these four formulas make up what they call the factor formulae of trigonometry. Remember, trigonometry is one of the most used topics in calculus. In fact, it is greatly applied in calculus. Though we have it in some algebra, but it is greatly applied in calculus. So when you have this this and this. Now you can do a lot of vast questions. We are going to have a few examples, and then we shall have work for you to try. Let's have some examples. I'm doing 1, then you do number 2, you do number 3. I'll do number 4, I'm doing 1 as you do the other, 1 as you do the other, so that we can learn as we enjoy as well. Prove that sine of x plus sine of 2x plus sine of 3x is equivalent to sine 2x into 2 cos x plus 1. We are looking at such a question. Somebody saying prove that sine x plus sine 2x plus sine 3x is equivalent to sine 2x into 2 cos x plus 1. Now, in your solution, look at the equation. Is it easier for you to come from the right-hand side of this equation, or easier for you from the left-hand side of the equation? If you choose which side to start from, then start from that side. It will be better. So, if you look at this, the left-hand side of this equation will be sine of x plus sine of 2x plus sine of 3x. Now look at this critically. When you look at it, you only have sine throughout. Your question must always be, I have sine x, I have 2x, and I have 3x. When you add x plus 2x, is there any way you're going to get an average of 3x? If the answer is no, please don't do the summation of this, because our purpose is getting the sum of different values here and then divide by 2. When you divide by 2, you're supposed to get an average that is easily factorizable out. So when you look at 3x and x, when you add them, can at any one moment get you an average of 2x? If your answer is yes, please bring this one closer and start from there. So we shall have sine x plus sine 3x plus sine 2x. When you look at this, this is an addition of 2 sines. Go back and look at what we said about addition. We say when you're adding sines, we say it is twice same sum, cos, same diff. Meaning you add this and divide by 2. As well, get this minus this and divide by 2. So we shall have 2 sine of x, because it is this plus this. Sine of x plus 3x out of 2 cos of x minus 3x out of 2. This one is exactly this. And this one reflects what we have exactly there, the summation of 2 sines, then plus sine of 2x. After this, now that the board has stopped here, I'm assuming that I'm still sloping down in my presentation up there. So when you add x plus 3x, you get 4x. 4x divided by 2, you get 2x. So we shall have 2 sine 2x. When you look at this, x minus 3x, you get negative 2x. Negative 2x divided by 2, you get negative x. So we shall have cos of negative x, then plus sine of 2x. Remember, a cosine is not affected by a negative. So this negative is important to be shown that you know and aware that when you subtract these two, you get a negative. After getting a negative, then you reason it out that a cosine is not affected by a negative sign. So we shall have, since sine 2x is common, put it out. So we shall have sine 2x outside the bracket into now, where there was sine 2x, we only have 2 cos x. 2 cos x. I'm ignoring a negative because it is on a cos. So plus, where we had this sine 2x, now that it is out, we only have 1, which is equal to, when you look at this and look at what they want us to prove, it is the same. So which is equal to the right hand side. And that becomes your answer. We are applying the factor formula. This second one is yours to try. This is the second one, and it is for you. Show that part A, cos x plus sine 2x minus cos 3x is equivalent to sine 2x into 2 sine x plus 1. Try this out. Also, you try this. Part B. 1 plus cos 2 theta plus cos 4 theta is equivalent to 4 cos squared theta cos 2 theta. Try out this question. Try out part A and B and find out how possible these answers can be got. Remember, the only person who can do a number that you can't solve is yourself. Even the person who wants to ask this question is also somebody's son, is also somebody's daughter. So if you have the concept, then you can find ways of applying it. So always have it in mind that the only person who can solve a mathematical problem that you can't solve is you yourself. Try it as many times as possible until you get the answer, because it has the answer. Now, the other question, I'm doing 2 more questions. So, let me rub off this. I don't want to rub off this. Why? Because I want to refer to them as we are solving these questions. Now we have this. Show that this is 3. Show that sine theta minus 2 sine theta plus sine 3 theta out of sine theta plus 2 sine 2 theta, then plus sine 3 theta is equivalent to negative tan squared theta out of 2. Now we are trying out this, hoping that you've written this, because I'm going to wrap it off. Now, look at this one carefully. They've told us to show that sine theta minus sine, twice sine theta, is it twice sine theta? Minus twice sine 2 theta. Sine 2 theta minus twice sine 2 theta plus sine 3 theta. Divided by this, you realize that what is up is the same as down. The only difference is in the sign. This only sign makes it different. Now, when you have this and the negative tan squared theta, the question will be, is it easier to prove this one from this side or this? To show this from this side or this side? If it is easier for you to come from this side to this side, it is okay. If it is easier for you to move it from this side to the other side, it's also fine, for as long as you get us the answer. So in your solution, when you look at the left-hand side of this question, the left-hand side is equivalent to sine theta minus 2 sine 2 theta plus sine 3 theta divided by sine theta plus 2 sine 2 theta, then plus sine 3 theta. If you have that, look carefully. This is sine theta, this is sine 2 theta, and this is sine 3 theta. The question will always be, when you add 2 theta to theta, can you get an average of 3 theta? If your answer is no, always make sure that you add angles whose average at one point will give you a value that is easily factorized. When you look at this, it is easier that theta plus 3 theta, you get 4 theta. It is easier to divide the 4 theta by 2 to get a 2 theta, which applies here. So I would wish that you always careful as you choosing what to add and what to subtract. Remember, these people are aware that people who set questions, we are aware that you know what to do, but putting this on last may confuse you and you rush on making action of taking this and this. So we shall say it is sine theta plus sine 3 theta minus 2 sine 2 theta divided by sine theta plus plus sine 3 theta, then plus 2 sine 2 theta. Do that before. When we are adding the two sines, we get twice semi-sum, cos, semi-diff. So we say it is 2 sine of theta plus 3 theta out of 2 cos of theta minus 3 theta out of 2, then minus 2 sine 2 theta divided by, hope the numerator is okay, divided by sine theta plus 3 theta out of 2, don't remember 2, don't forget a 2, sorry, then cos of theta minus 3 theta out of 2 plus 2 sine 2 theta. What about this step? After having this, look what is possible for the answers after subtraction and addition. From here, theta plus 3 theta out of 2, you end up getting 2 sine 2 theta. 4 divided by 2. Then cos of negative theta. Remember, a cos is not affected by this negative. Minus 2 sine 2 theta out of 2 sine 2 theta. Here, cos of negative theta. Then plus 2 sine 2 theta. Look what the numerator and the denominator. Do you realize that 2 sine 2 theta is common up and 2 sine 2 theta is common down? If you realize that, then factorize it out. Don't just say, this sine 2 theta is common here. That is not mathematics there. It is true. It cancels out. But how does it cancel out? It only happens if this one is factorized out and put into a product such that it is a product to the bracket. That's when you can cancel. So we shall have 2 sine 2 theta put out. Inside here remain with only cos of theta minus 1. Now that sine 2 theta and the 2 have been moved out, remaining with 2 sine 2 theta divided by, do the same down. We have 2 sine 2 theta and there is 2 sine 2 theta as well. So we have 2 sine 2 theta into, now you have cos of theta plus 1. I told you the negative does not affect a cos. So when you look at this, this now shall cancel with that one. So we shall have cos of theta minus 1 divided by cos of theta plus 1. When you get to this level, you can either rationalize and do the needful, or you go back to double angle and buy a level from there. Remember, from double angle, from cos 2 theta equals 2 cos squared theta minus 1. When you divide this angle by 2, this angle shall also divide by 2 to get a half angle. So we shall have cos of theta giving us 2 cos squared theta over 2 minus 1. Still, from the same ratio, cos 2 theta is 1 minus 2 sine squared theta from double angle. So when this angle divides, also this one divide to create a half angle. So you'll have cos theta as 1 minus 2 sine squared theta over. When you look at this, get this one and bring it to this side. You will get cos theta minus 1. Get this 1 and bring it to this side. You will get cos theta plus 1 equals 2 cos squared theta. Here you will get cos of theta minus 1 equals negative 2 sine squared theta. This is for your own consumption. It's not an exam. If you remember this very well, just do the substitution. So we shall have, instead of cos theta minus 1, we shall put negative 2 sine squared theta over 2 out of, instead of cos theta plus 1, we shall put cos theta, bring this one here, it becomes cos theta plus 1. So we shall put 2 cos squared theta over, so the 2 will cancel out. Remember, we are proving this. After 2 cancelling out, remain with a negative. Sine divided by a cos, we get a tan. So we shall have negative tan squared theta over 2, which is equal to the right hand side. And that one becomes your answer. There is one more question that I want us to do. If we're given a product, how do we take it to a sum? This is example, I think 3 of, it is example 3. 1, 2 was yours, 3, this is 4 now. Example 4. For now, show that sine 3 theta sine 6 theta plus sine theta sine 2 theta divided by sine 3 theta cos 6 theta plus sine theta cos 2 theta is equivalent to tan 5 theta. For this one, all I'm going to do is guiding you on how to turn this product into a sum. When we turn it into a sum and a difference like this, then we will continue and improve this. What I'm going to do is helping you now. How is this one disseminated into a sum and a difference? How is this one done? But before doing this, your mind must have the 4 equations under this. The factor formulae must be in your mind. You must be aware that whenever you have a sine plus a sine, we will always get 2 sine, semi-sum, cos, semi-div. You must know that whenever you have sine minus a sine, you will get 2 cos, semi-sum, sine, semi-div. You must also be aware that we are having cos plus a cos. We normally say it is twice cos semi-sum cos semi-div. Also, lastly, you must be aware that it is cos minus, we shall always have twice negative sine, same sum, sine, same diff. So these ones must be in your mind. That whenever you have cos minus cos, cos plus cos, sine minus sine, sine plus sine, what do I get as a result? If you know this, then this one becomes a bit simpler. Now look at this. Somebody is saying sine 3 theta, sine 6 theta. The moment you realize the sine and the sine, what difference or what sum that give us a product of two sines? It is only the difference of cosines that give us a product of sines. If you realize that, then you know the product of two sines shall equal negative a half, hope you see it from there, into cos of A minus cos of B. When you divide this by negative 2, you end up getting this now. Now the question has given us this, and this is what they want. This question has given us this is what they want. How do we get this? So you create a half. After creating this a half negative from there, so you say it is negative a half in. How do you get A? Get this plus this, don't divide. 3 theta plus 6 theta, so you realize it is cos 9 theta. It is cos 9 theta, then 3 theta minus 6 theta, because we know it is a difference of two cosines, minus cos 3 theta minus 6 theta, which is negative 3 theta. Remember, this is not affected by a negative. So practically, this is what they wanted here. So when you look at this, sine 2 theta, so it is sine theta, sine 2 theta. This is as well simple. Now that sine is a result of a difference of cosines, this is negative a half just here into cos theta plus 2 theta to 3 theta. Theta minus 2 theta minus cos of negative theta. When you're turning from a product to a sum or a difference, don't divide, just add. For as long as you know what brings this. The same story here, the same story. Now look at this. This is sine cos. The only sum or difference that gives you sine cos, it is the sum of two sines. The sum of two sines will give you a product of a sine and a cos, writing sine first. So you do that before. That sine 3 theta cos 6 theta equals a half but positive into, now you know it is a sum of two sines. Sine of 3 theta plus 6 theta, you get 9 theta. You see? Then plus 3 theta minus 6 theta, you get cos of negative 3, so sine of negative 3 theta. But remember, because when you get this, you get negative. A sine is affected by a negative, so it will be 9 sine 9 theta minus, because the sine of negative 3 theta is the same as negative sine of 3 theta. This is the same. So you apply this one here, the negative will affect this positive. After putting this one, you got sum and difference, sum difference, then do the needful and prove that yourselves. I will just want to guide you here, and you take this one up to its final destination as regards the answer. Now I'm going to do one more question. After that one more question, I'll give you what to try as well. This is another example. I think example 5. Example 5. If A, B, and C, if A, B, and C are angles of a triangle, are angles over triangle, angles of a triangle. Prove that. Prove that. Part A. Of these ones, I'll do part A only. You're going to do part B yourselves. Part A, prove that cos of A plus cos of B plus cos C minus 1 is equivalent to 4 sine A over 2 sine B over 2 sine C over 2. Then part B, I said I'm doing only part A and you will do part B. Part B, sine of A plus sine B plus sine C is equivalent to 4 cos A over 2 cos B over 2 cos C over 2. When you look at such a question, someone says if A, B, and C are angles of a triangle, in telling you these are angles of a triangle, this person is testing you. Are you aware that the angle sum of a triangle is 180 degrees? If that one has come into your mind, now look at the expressions they are giving you. Sine, sine, sine. Cosine, cosine, cosine. So it is an addition of two sines. An addition of two cosines. Now in this sense, we are going to do part A in particular. We are going to do part A. When you look at this, it is cos of A plus cos of B plus cos C minus 1, that is equal to 4 sine A over 2 sine B over 2 sine C over 2. It is easier when you look at this coming from the left hand side to the right hand side according to this question. If you realize it is easier that way, what you do, look at this. You can decide to say, let me treat cos A and cos C as a sum, then I do cos B minus 1. That is very okay. You can say it is cos B plus cos C using the factor formula now. Then you consider cos A minus 1. Then some other person may say, I'm considering cos A plus cos B and I consider cos minus 1. So there is no permanent route can take you to the answer. Everything, so long as it is mathematically right, it will take you to the right answer. So in my solution, if you look at the left-hand side of the question, the left-hand side is the same as cos of A plus cos of B plus cos of C minus 1. That's the left-hand side. When you look at these two, I'm going to treat them using the factor formula for addition of two cosines. When you add a cos plus a cos, we say you get 2 cos same sum, cos same diff. So we shall have 2 cos of A plus B out of 2, cos of A minus B out of 2, plus cos C minus 1. Now, when you look at this, do you realize that this person telling you these are angles of a triangle, this person wanted you to get a sum that is going to 180. So, for A, B, and C, for angles of a triangle, so we shall have their sum, A plus B plus C, giving us 180. In that sense, A plus B shall be 180 divided minus C. Now we have A plus B just like you see here. And this one is a half angle, is divided by 2. So what you do, you follow suit. We divide this by 2 and this one by 2. You will have A plus B out of 2 shall be the same as 90 minus C over 2. When 2 divide 180, you get 90. When divide a C, it remains. When you look at this, introduce cos on both sides such that you have something of this kind. So we shall say when you put a cos of A plus B out of 2 shall be the same as cos of 90 minus c over 2. Expand this such that you get cos a plus b over 2. It's a figure as regards to this. When you expand this, you end up getting cos of 90 cos c over 2 plus sine of 90 sine c over 2. Now remember, wherever you're having this, we know the value of cos 90. You can find it with a calculator. If not, you can find it from a curve. You know that. Look at the cosine curve. It starts like this. That will be a cosine curve, implying that if this is a unity and this is 0, the cos of 0 is always 1. When you come to this, you make a quadrant. So the cos of 90 now becomes 0. So the cos of 90 is 0. If the cos of 90 is 0, everything here becomes 0. But for sine, remember, when I don't have a calculator here, so I'm using a curve. The sine curve shall start from somewhere here. The sine curve. This is a cosine, this is a sine curve. For a sine curve, it makes a 90 at exactly 1. This is a 90, it makes at 1. So the sine of 90 becomes 1. If the sine of 90 becomes 1, so this one is 0, and this is 1 times sine c over 2. So we shall have this one as sine c over 2. After realizing that cos a plus b over 2 equals sine c over 2, now you're sure of what we put here. Remember, the answer is in terms of sine, yet here we have cosines and so we are struggling to take all the cosines into the sines that these people want. Now look at this. From double angle, we normally say cos of 2c is equivalent to 1 minus 2 sine squared c. This is a double angle. Remember, what we are doing here, we are talking about half angles. These are half angles. So you divide this angle by 2. The moment you divide the angle by 2, the angle also divides by the same margin that you've done this side. If you divide by 3, this one will divide by 3 as well. Only the angle. Take note of that. This one shall divide by 2 as well. So you'll have cos of c giving us 1 minus 2 sine squared c over 2. Now look at this. Here they've given us cos c minus 1. Get this one, bring it to this side. So you'll have cos c minus 1 giving you negative 2 sine squared c over sine squared c out of 2. So you have a substitution for this now. After realizing you have this and you have this, continue. So we shall have. So in an exam, if you know this, you just need to substitute this with this. Because this one is standard, it is known. If in an exam, you can just substitute this with this. It is okay. We are doing it for purposes of learning. And with practice, it becomes part of you. Now, when you come here, I'm assuming I'm still sloping with this. So we shall have the left hand side still equal to, instead of cos a plus b over 2, we substitute it with this. So we shall have sine c over 2 cos a minus b out of 2. Then, with the plus, instead of cos c minus 1, we are substituting with negative 2 minus 2 sine squared c over 2. When you look at this, there is a 2 here that we have forgotten. There is a 2 here that we have forgotten. When you look at that, 2 sine c over 2 is common on both. So factorize it out. You'll have 2 sine c over 2 into cos a minus b out of 2. Then minus this 2 sine c over 2 have moved out already. Here you have sine c out of 2. That is what you have. But remember, sine c over 2 is the same as cos of a plus b over 2. So we will have 2 sine c over 2 into cos of a minus b out of 2 minus cos of A plus B out of 2. When you look at this, you can either use the factor formulae for cosines, the difference between cosines, or you may just expand this and see the answer you're getting. When you opt to expand 2 sine C over 2 into, expand this, it becomes cos A over 2, cos B over 2, plus, because this is minus, so it becomes plus, sine A over 2, sine B over 2, minus, discuss space. Hope this one is okay. I'm going to pull a little so that it can fit. I hope this is okay. So I'm rubbing this one off so that I can pull this one a bit. This. Yes. So we shall have 2 sine C over 2 into cos A over 2 cos B over 2 plus sine A over 2 sine B over 2. This is minus. We are subtracting. Remember, this is a positive. It will create a negative inside there. So we shall have cos A over 2 cos B over 2. Again, minus, because this is a plus now. Minus sine A over 2 sine B over 2. This is sine A over 2, sine B over 2. It is not visible so well, but it is sine A over 2, sine B over 2. When you open this bracket, this one becomes positive. Sorry, this one becomes negative, but this one will become positive. So we shall have 2 sine C over 2 into. Now, this one will cancel out with this because it is negative. So we shall remain with sine A over 2, sine B over 2. Plus, this negative affects this negative to become a positive. Sine A over 2, sine B over 2. So when you look at this plus this, you get twice sine A over 2. 2 sine A over 2 times this 2 becomes 4 sine A over 2 sine B over 2 sine C over 2. They arrange and get the answer they are interested in. So we shall have 2. This is 1, this is 1, then we need 2. So we shall have 4 sine A over 2, sine B over 2, sine C over 2, which is equal to the right answer, right hand side. And that is all they wanted. So for all questions, you will have to try this. For all these questions, what you need to know is how do they treat the half angles when you apply the factor formula. You need this for your consumption. Always be careful when they are writing this. Thank you so much for learning with us. Make sure that you don't forget to subscribe, share, and like. Share this work with some other people that may need it. Thank you so much.